Oh, it is going. Hello, everybody. Welcome to this month's Future in Space Hangout. My name is Tony Darnell. I work at deepastronomy.space, and you are watching our monthly hangout where every month we get together and talk about what's happening in the future, what's coming up. What in particular, we talk about things that are in human space flight as well as space astronomy, all kinds of stuff. So this hangout is your monthly fix on the future and where we're headed. And today's topic is going to be on policy. How do we make decisions about what kinds of things we're going to do in space? Now, my guests today are policy experts and people who get involved in the areas of space astronomy in particular, and we'll talk maybe if we can get into some human spaceflight policies as well, if they have some comments or opinions on that. But that we'll get to that as the hangout progresses. I want to mention a couple things I always am really bad at doing. So let me do this right now up front. If you want to know what hangouts are coming up, go to deepastronomy.space/hangouts. I have a Google Calendar there that I've gotten really good at putting all the events in. So as soon as they've been finalized, Harley and Carol and others tell me what's going to be on the hangout, I make the event in the calendar and I post it there, and you can see it on the web page. You can subscribe to that calendar. It's public. You can make it part of your calendars and get notifications. So please check that out to get notified of what's coming up in Hangout Land. And also, after this hangout, I'm going to be stopping this particular stream, and then I'm going to head over to Twitch, where we will do a Q&A after the hangout. It'll probably be just me, and I'll just hang out with you guys for a little bit, and we'll do some more talking on Twitch. So join us for that if you have time. I am also testing a new chat client on Discord. I won't probably use it for the hangouts per se going forward. I just want to test it during this hangout because I want to see what it can do, and I might use it for Patreon patrons in future events that I'm planning on holding. Having said all that, I am now monitoring YouTube live chat, Twitter using the Future in Space Twitter handle, as well as I'm on Facebook. I'm looking at the Facebook stream, and I'm on Twitch. So please leave your comments and questions for our guests today, and I will read them out as the hangout progresses. Phew, I think I did it. Okay, so let me go ahead and pull up my co-host, Dr. Harley Thronson. Hi, Harley.
Hi, good afternoon. Good afternoon, everybody.
It's good to see you. How about you want to introduce our hangout and maybe tell people what we're doing and why?
Sure. Yeah, absolutely. The issue has come up, and I think we're coming up to about 2 years. That is about 20 previous hangouts. Very commonly, the question comes up from the audience. Well, we'll talk about the science goals. We'll talk about possible future missions and so on. Well, how are these science goals translated from really good ideas from the science community into missions? It's for many folks, it's a black box, and an unnecessary black box. NASA, the National Science Foundation, the astronomy communities, the professional societies, particularly the American Astronomical Society, one of our sponsors, has established for many decades a process now well regarded, well respected, to turn, as I said, good science ideas, possible technologies, possible designs into real missions. It takes a couple of decades. Maybe takes several runs through this process. But that's what we're going to talk about today. How do we get from a grand idea to hardware in space? So what do you think? Shall we?
Yeah, let's go ahead and do it. Let me pull up my scientific Brady Bunch here. There we go. Here's everybody. Okay, my guests today, let me introduce. In the upper right corner or upper left corner are the two people that work for the American Astronomical Society. On the left of that little square is Dr. Ashlee Wilkins. She is the Bacall Public Policy Fellow at the American Astronomical Society. Welcome, Ashlee. And right next to her is Dr. Joel Parriott. He's the Director of Public Policy at the American Astronomical Society. So welcome, Joel.
Thank you.
And in his own little square, looking like the Dark Lord and with his bad lighting, is Dr. John O'Meara. He's a professor and chair of the Department of Physics at St. Michael's College, among a great many other things. I follow him on Twitter. He's a lot of fun. Welcome, John. It's good to see you.
Good to see you, Tony. How are you?
I'm good, thank you. Great. Okay, so big news this week, huh? Did you guys hear about all that gravitational wave stuff early on Monday?
All that bending of space and
All
time.
that bending, that rippling of space time was pretty good. That's pretty exciting news, right?
Yeah, I think it was terribly exciting news. Although I'm going to defer to our three guests because the things that we all care, but the things that they care much about is engaging the science and the public and the policymakers. So they may have their perspective on how exciting it was to those folks.
Yeah, in case you've been living under an astronomical rock, what happened was back in August, the people operating the Laser Interferometer Gravitational Wave Observatory and the Virgo Observatory, which in Italy, this is our big three components of a gravitational wave observatory, detected for the first time what they think are two neutron stars merging. And when it did that, it was cooler than black holes for reasons we'll get into in just a minute. But when it did that, it sent out gravitational ripples through space-time that were detected by these detectors. And unlike black holes, when they merge, they just merge and send out ripples, which is pretty cool. Neutron stars do a lot more. They actually explode. They let off a lot of electromagnetic radiation, and that was captured by a lot of other people. So what did you guys think? John, let me start with you. What did you think of that announcement?
Oh, I thought it was really one of the cooler things I've seen in quite a while. I was actually at NASA Goddard, and we were working on some things we'll be talking about later today with LUVOIR, and we all stopped doing what we were doing so that we could watch the press announcement live. A lot of us had known that something big was coming. I don't think a lot of us knew the extent to which so many different facilities were observing this event simultaneously. So the big deal to us was that, not like you said, not only did we get the gravitational wave signature, but we detected it in gamma rays, we detected it from telescopes on the ground, and so we could build up this amazing amount of knowledge about this event all across the EM and now gravitational wave spectrum, and that's really, really exciting. And it was it's also just it's nice to see a whole new field of astronomy just being born and catching its first big successes.
I know, it's really amazing, isn't it? I mean, we really are living in a new era of astronomy where an entirely new I guess it is a wavelength, isn't it? Is now visible to us. I mean, it's not an electromagnetic wavelength, but it is still a window into the universe that we can now observe.
I like to call it multi-messenger astronomy, and we've really now just hit the ground running with it, and it's going to be exciting to see where we go with it.
Yeah, it's really cool. So what did you guys think of it? What did you guys think of it there, Ashlee and Joel?
I thought it was awesome to be able to see, I think particularly watching during the press conference and reading the paper, the progression of how everything worked how it was supposed to, in that first you saw the gravitational wave, Fermi saw the gamma ray burst. You had to wait until the sun went down so that observers on Earth could actually observe it, but you could, telescope after telescope, found the object, and 70 plus observatories in line to see this one event, and supporting and bringing together theory and observations, because we knew that this was what we should see, and then we actually can see it. I just thought it was awesome.
Yeah, what do you think, Joel?
Yeah, I was saying, for people that live and work in Washington, D.C., we get jaded and cynical, and it's really awesome to get something this cool happening in the world of science. And to toot the AAS's horn, we ended up publishing, I think, 27 different articles and AppJ letters that came out same time as the press conference. So I sort of knew what was coming, but it's...
Now that's an interesting point. I'm glad you brought that up. People don't realize that the AAS actually runs some very the Astrophysical Journal, which is a really important astronomy journal, isn't it?
And so, if anybody listening in, we've made those articles free to read for the rest of the calendar year. So if you want to go peruse them, just Google probably APJL and gravitational waves, and you'll find it.
Oh, that's really, because ordinarily, because this is a scientific journal, you need a subscription to be able to read these papers.
Normally we have stuff embargoed for 12 months, but right now we're making this free to read.
Oh, I didn't know that. So after 12 months, all the articles are available?
Yep, everything.
Well, that's
Not
cool.
all publishers are like that, but we are.
Well, to me, what was amazing was within, I think I heard 2 seconds of LIGO Virgo saying they found something. They have this alert system that that astronomers all over the world are a part of, and I think within 2 seconds of that happening, Fermi was able, the spacecraft that looks for gamma rays up in space, was able to get an observation less than 2 seconds after that happened. And they did, in fact, see a gamma ray burst in that area of the sky. And you know who does all the coordinating of this stuff? This is amazing, because the astronomers, this doesn't just happen, this coordination. They have a very special thing that they use. Harley, show them the person in charge of coordinating all astronomers throughout the world. Show them our little gravitational rubber ducky.
Okay. All right.
Come on. This is it, folks. This is how it happened. That's the magic right there. Okay? Astronomers around the world. There you go. Thank you, John.
John, thank you so much.
It's GW.
Yep.
And that's not George Washington. That's gravitational wave rubber ducky. And
when the rubber ducky detects
and he does it by floating on space-time.
Exactly. Then it sends out an alert that all astronomers around the world listen for.
Okay. We've taken this about as far as we can go.
When we go off the air, I'll tell you why the rubber. There is a reason, and our regular viewers may remember why the rubber ducky is the central ganglia.
Okay.
Communication system.
So Adam Synergy just commented in the chat, Joel, that the papers are also free on AstroPH or AXR, what's it, ArcsIV or something? I don't know how you pronounce that. But on AstroPH, those aren't the final versions, though, is it? What's on AstroPH?
It should be actually linking to the final published version. There are some preprints that got released then too that we had just accepted by the journal, but they haven't ended up in full copy edited final state yet.
Okay, well,
so,
I want to. Okay, well, I wanted to thank you guys for commenting on that story. It was a big deal, and I felt like we'd be remiss if we didn't at least talk about our opinions on one of the biggest discoveries to happen in a while. I'll have more on this on Spacefan News next week. Okay, so today we're here to talk about, however, policy and getting into space, studying space with telescopes that go there, and one of the big things that let's just get this out there right now because it's going to come up. The James Webb Space Telescope is currently being built and tested. It's on its way. It's still at Johnson, being whatever it's done, warmed up after its cryo testing.
And being prepared to be, and I don't know exactly the schedule, being shipped to Northrop Grumman in Southern California for.
Yeah, I would point out only part of it is in Houston. The other part is in California with Northrop Grumman, and that's the part.
Yeah, that still has yet to be tested, and that's the heat shield and or I should say the sun shield. I get in trouble every time I call it a heat shield. The sun shield and the thing that's got to deploy and all of the rest of the spacecraft bus, all of that gets shipped and put together in one big giant thing where they have to test it as a final observatory, and that's happening next in Redondo Beach, California, at Northrop Grumman's facilities. And if Alberto is here, he could tell us a little bit about what they're going to do, but he'll be maybe in a future hangout. So it's delayed, folks. It's not. It was supposed to go in October of next year, 2018. And now it looks like they've added up all the things they need to do test-wise. And I don't have to tell you, folks, that this has to go right the first time. And if anybody's ever seen that deployment video that Northrop Grumman put out on what JWST has to go through after launch, you really do want them to do this. And so they're testing. They need more time for testing. So now JWST won't be launching until at least March of 2019, maybe as late as June of 2019. What do you guys?
I'll put this to Paul Hertz, who runs astrophysics at NASA, but he said something to the effect of he has a hard enough time folding fitted sheets, so he can understand why Northrop Grumman would have a hard time making that shield work.
Yeah, and I have no problem with this. I think fine. It can be delayed. That's fine with me. I'm anxious. I'd love it to be launched, but what I don't want is any kind of disaster. So I absolutely want the people in charge to feel comfortable with what they've built so that when they do launch it, everything unfolds. Because we're looking at a 6-week, I think, deployment period where after this thing gets launched, they've got to slowly unfold it, unfurl it, get it out to L2. I mean, it's scary. Anybody who's, and we all want it to work right. So while it's disappointing that it's going to be a bit of a delay, I'm okay with it. What do you think, John?
Well, I mean, the first thing I would say about it is that everything you said is right. You want to test as much as possible in an environment that you can control, so that you understand all the ways that the thing is supposed to work, and to make sure that it's working right. The other thing that's important to note, at least about this delay, is, at least in my understanding of this delay, is that that still doesn't impact the cost of the mission currently.
No, that's right. That's an important point.
Within the margin that they have for the expected expense for the mission. So we're not incurring additional costs. This is within the margin for the mission if it launches on the time scale that they've specified for the delay. But other than that, all I would do is echo exactly what you said. JWST is an extremely powerful and complicated observatory. And
the biggest we've ever put into space so far.
The biggest we've ever put into space so far. LUVOIR will be larger. Wink, wink, nudge, nudge. But it is an extremely complicated, precise facility. The one that I like to echo is that it could detect the heat of a bumblebee on the moon. And when you have something that sensitive with that's complicated to deploy sequence, you want to know that it's right. And so I think the decision-making process, especially since we reassessed and redid the way that we were planning the observatory and all that stuff that happened a few years ago, things have been going very well, and we're still going to be on budget if we get launched right. And I think that last statement is actually rather germane to what we're talking about here today. Which is the idea of large missions, how they come to be, how they come to be paid for, and what we expect out of that whole process, both as astronomers and as taxpayers.
That's correct. So let's go ahead now. I don't know if it's okay to jump. I mean, we're on JWST, and maybe we'll just say a little bit about your comment about not really going into the budget. It's not going to increase the budget. That's because in all missions, and anybody can comment on that if you want to, all missions have contingencies built into their budgets, correct? Maybe talk a little bit about what they're for and how they go into the final dollar price tag, don't they, of these telescopes? Anybody want to comment on why, even though JWST is delayed, it's still not going to be increasing our budget? Or the budget of the mission?
I can, and my colleagues here can add to it. I mean, I can comment on that. I faced a bunch of such situations that when these missions early in the design period, very, very experienced scientists, engineers, technologists, cost experts make estimates of what it will cost to eventually build and launch and operate these missions. But they are estimates, and they are recognized to be estimates. And increasingly sophisticated mathematical tools allow one to put an estimate of the uncertainty. They allow one to calculate the uncertainty, and that uncertainty then becomes contingency costs. Just to give folks a rough idea, my memory is that typically a big mission has adds in about a 30% contingency. Things that 10 years in before it's finally built, you weren't able to estimate correctly. Surprises, delays, as we heard with JWST. And it's the reality of any kind of program and project. Folks who may have wanted to upgrade their kitchen, for example, discover that, well, all the parts weren't there on time, labor costs, there were delays, there was weather, and so on, uncertainties. And the contingency is, as it's referred to, the contingency, typically about 30%, is designed to cover those uncertainties in a mission cost and a mission schedule.
And how would have been happy with that with my last kitchen remodel. 30% would have been much better than what I ended up paying.
Extension on your house, or whatever. Your holiday vacation. It's there's going to be an uncertainty. You build that into your design. You build that into your schedule. You build that into your budget, and it has exactly the effect that John described with JWST. It wasn't expected. It happened. But the delay in time and the cost is covered by the contingency.
Okay, now I'm going to ask a question. Go ahead. Did you want to say something, Ashlee?
Oh, just so in practice, so like with JWST, that contingency or that reserve amount of money, it's not like the whole team hears how much is contingency and how much is still there throughout the course of the mission. It's held for Webb, it was held by headquarters. And when they have both budget and money contingency and then schedule padding, so the same thing where in the schedule you kind of allow for extra time in your planning. And so what's happened with Webb is basically they've run out of schedule contingency, of schedule reserve.
With this latest delay, you mean?
Well, they realized when they had to make an assessment a year ahead of time out from October 2018, we don't have enough time to do everything we need to do in the next year, so they can use the budget reserve. NASA released the money that they have, headquarters released the reserve that they were holding for them for an extension of the schedule, because of course adding a delay, even if you have all the parts, you have to pay the people for those extra months to continue to monitor to continue to do the testing, to continue to just watch the telescope.
And that's what they call marching army costs. And I think for Webb in this final phase, I heard a number, it's like $25 million a month, something like that.
Now so they had to actually make a science, or not a science case, but a mission case to NASA that said, hey, wait a minute, we're not going to make it. And NASA had to buy off on that, correct? HQ? Okay, all right.
But I think this delay is relevant to today's topic, which is there's a discussion right now on whether this delay in Webb is going to necessitate a delay in the community's plans for the next decade through what we call decadal surveys. Are we going to delay it by 6 months or a year? Or are we going to proceed ahead on the schedule of the National Academy of Sciences that already laid out? So that's active discussion right now.
So wait a minute, I don't understand. This could delay what schedule? The schedule of science?
No, the schedule for the National Academy of Sciences decadal survey process, which is the process by which the community all come together. I think something like a third of the community ultimately participates in it. And it's a planning process that takes 2 or 3 years and happens every 10 years. It started back in the 60s, and the community's been doing it every 10 years. And this current one, because of the delay of Webb and how important Webb is to the entire field, the question is, should we wait to start our planning process and deliberations until we know what's happened with Webb?
The planning process for the upcoming decadal survey in 2020.
The 2020 decadal survey, yeah.
Okay.
Yes, Tony, if I could just give an example, it would.
Go ahead.
Take the LUVOIR mission as an example. Like LUVOIR is intended to be a very large segmented mirror telescope, and we're submitting our proposal as input to the decadal survey, and it would make a lot more sense if we knew that Webb had deployed properly, that was stable to the degree that we wanted to do as a technology demonstrator. You would want to have that information be available to the decadal survey. You would also want to be able to see what some of the initial science return from Webb is, because you want to be able to see how that impacts a lot of the input things that the community would be saying. Now that we know Webb works to this scientific accuracy, now we know the kind of science portfolio it can conceivably address over the lifetime of its mission, we can set our priorities based off of an expected return from the observatory. If we had done the decadal prior to Webb's launch, it would be this looming question mark that would filter down onto almost all the layers of the things that we would want to do after that.
Okay. So for those of you who just saw that, my battery almost went dead on my camera, so I had to hurry up and plug it in. All right, good. So with the so John, you're working on the with the LUVOIR mission, and we've had other people on here talking about what that mission is, and you are actually a candidate mission for the next decadal survey. Is that a right way to put it?
Yeah, I think the way that I would put it is that a few years ago, Paul Hertz, recognizing that the decadal was coming, put a call out to the community for membership in 4 science and technology definition teams. These are teams of people, astronomers, engineers, etc., to come together and create 4 large mission concept studies. So this is basically soup to nuts studying the science case needs and the technology needs, and all putting those things all together to come up with mission concepts that we can then deliver to the decadal survey to see whether or not the Decadal Survey wants to prioritize one more zero of any of those missions for start in the coming decade. Because of the scale of those type of missions and because of the costs associated with them, you want to do as much homework on the front end as you can to be able to give the Decadal everything that they need to know, both scientifically and technologically, in terms of what we would need for technology development, for example. Or are they answering the questions that the community sees us wanting to answer over the next 10 to 20 years? And so we're doing our homework now. We're building a mission concept study for LUVOIR and for 3 other mission concept studies. And it's a 3-year process that will then hand this off to NASA and then eventually the Decadal as part of their deliberation.
So, Joel, you were saying this has been a process we've been going through since the 60s. Hubble, pardon me if I'm saying this wrong, but I think Hubble was a product of one of the Decadal surveys. Am I right? It was listed as a high priority.
Yeah, I think it came out of maybe Harley knows, it's either the 1970 or the 1980 Decadal Survey.
Yeah, good question.
But the fact is, it was done in one of those surveys, and then over a decade later was launched. If it was the 70s, it was 20 years. If it was 80s, it was less than 10 years. JWST was also one of those, the outcome of a Decadal survey, and it's now getting launched. So my question has to do with this schedule you were talking about. How, I mean, these things are decided on, prioritized, and given a green light decades before they launch. Is the schedule really that tight? I mean, is it going to mess up, for example, John's LUVOIR stuff if JWST launches? You're saying there's a debate going on right now.
Well, it's just a debate about debating. So,
okay.
So it's more, when is this? So my first job, I've been in DC for 19 years now. And my first job in town was at the National Academy of Sciences. I was staffing the 2000 Decadal Survey. And it's a terrible name, Decadal Survey. People outside our community don't know what you're talking about. It's not a survey the way you're thinking of it. Decadal most people get, but they don't understand why that's in the title. So what it really is the survey comes along from the community, forms a bunch of committees who then survey the state of the profession, the state of the science, and make a report. So what I was amazed by coming fresh out of grad school then was there's this huge dormant machinery that all of a sudden every 10 years springs forth to do the Decadal Survey process, as we call it. So what's debated right now is, are we going to wait to turn that machinery on? Are we going to delay it by 6 months, 12 months, or are we going to start up the machinery right now?
I see. Okay. Well, I've joked before with Harley on this, but I think that as far as the Decadal surveys go, that one day it's gonna turn into an awards ceremony. It's gonna be an awards show, and I'm calling it the Deckies. And they're gonna get together. The entire astronomical community is gonna get together and find out who wins the #1 spot in the Decadal survey. This year's Decadal survey, the winner goes to LUVOIR because it is going to
Mission Concept Survey of the Decade.
Exactly. All right.
Okay. By the way, I've got a question for Ashlee. So if I recollect, Ashlee, you are newish arrived at the American Astronomical Society.
I am.
Yeah, correct. And so one of the roles that the American Astronomical, it's our professional society, all of us are astronomers. It's our professional society. So what is the role that you play? Joel obviously can answer as well, but Ashlee, what's the role that you play in general? And then with respect to this particular process, does the American Astronomical Society have a role to play in the assessment of possible future missions?
So I just finished my PhD in astronomy in August. And so I just came onto the American Astronomical Society in the last 6 weeks or so. And my role as the Decadal Public Policy Fellow is to both communicate with folks in DC, with decision makers, with policymakers, DC, on what's happening in astronomy, on what the priorities are for the science community, on specific issues and on the big picture, but then also communicate with our membership, which is professional astronomers, And that's the large term that means astrophysicists, planetary scientists, heliophysicists, on what's happening in DC. So they know what's happening with the budget process. Harley, you've got a visitor.
I know.
So that's broadly my role. And so at the AAS, so Joel is on public policy half-time, and he's the one in charge, but because he also has to wear his hat as running the journals, I'm the only full-time person doing policy. So that's what I do all my days, most of my days. In terms of our input as a society to the process, we are here to support the process. So a lot of times with the Decadal Survey and with the National Academies, it might just be that we are an extra connection directly to the community. As Joel said, this is kind of a machinery that mostly wakes up only every decade. So it's about getting connections to who should be on helping recommend people to panels, or recommend or getting connected to this is what's happening in the community. These are the issues the community is concerned about, and informing and keeping the policymakers also connected to the decadal surveys. That's the work that we do whenever we talk to folks on the Hill, for example, is always about, it comes back to what are the decadal survey recommendations. And so that, because those represent what the science community wants, more or less unfiltered by anything else.
Thank you. I think one of the things that's important to point out here is that, and Joel, actually, all three of you guys have been referring to the decadal survey process. I don't know if we need to go into the details, but the National Academies are contracted by the National Science Foundation and NASA to carry out this process. And the National Academies does a very good job at surveying the scientific community. Conferences, workshops, subcommittees are set up, and it goes on, just as Joel was saying, 2-ish years before the final report comes out, which consists of a lot of opportunities for the professional astronomers to have input into the process. I think it is the case that in the 2010 decadal survey, 300 professional astronomers, 1,000 or more astronomers had input into it, but there were 300-ish or thereabouts who were actually on some committee, some study team, and of course the central ganglia, or whatever it's going to be called, the Supreme Soviet, the 30 or 4 folks that will write the final report. But there's a huge amount of community input, debate, discussion, celebration and pain when the whole thing is over. And I think it's important to note to the audience, and we can start getting some questions about this, who receives the report? So to whom is the report directed? John, Joel, Ashlee?
So it's asked for by the agencies, so they're the recipients of it, the NASA, NSF, and now for the last 2, the Department of Energy's Office of Science has sponsored it as well, because they care about dark energy, dark matter, these kinds of things. Well, yeah, a little dark matter, mostly dark energy. But as it comes out, the key people who really care about it, as well the other stakeholders beyond the community, is Capitol Hill. And the White House pay a lot of attention to the report as well, because it's there. You get lots of lobbyists coming in to see you about specific missions, and you need something to refer back to, which is a consensus opinion of the entire community and what those priorities are in ranked order. So if somebody comes to you and says, I have a great idea for a mission, when I used to work at the White House Budget Office, I would pull out the report and I would say, okay, show me where that is in the report.
Right. I think that's a very important point. I used to do a little bit of advocacy on the Hill. As a civil servant, can't do much of it except under very, very specific circumstances. But my experience was very similar to what Joel and I presume Ashlee is having as well. So maybe John is also, you're almost literally exactly the case. Lots of scientists, industry, universities, we really have this exactly, you said it exactly right. And there will be, one hopes, a well-thumbed version of the decadal survey, and the folks on the Hill will say, well, several thousand astronomers weighed in over the past X number of years. So show me where your brilliant idea fits into the decadal survey priorities. And in the budgets or the appropriations for the agencies that we get every year, they will note that this or that priority, the missions, for example, are consistent with the decadal. They'll note explicitly that it's consistent with the decadal survey. So it appears in appropriations. I'm sorry, Ashlee.
Oh no, and the decadal surveys, they really do a good job, and I think this is why they become so useful. Is it's not just what astronomers wish they could do or what we would do if we had unlimited funds. They very clearly, and it's not just a single priority. It's not just JWST that came out of a single decadal. We prioritize at every mission class under the consideration of what we think the budget is going to be over the next 10 years, knowing that you can't know what the budget's going to be like for a full decade, but it's meant to be realistic and specific, and recommendations and priorities are made at each for very big missions, for small missions, for ground-based observatories, and all of that is kind of put together. So it's a really nice roadmap, and this is done in astronomy, in planetary science, and in heliophysics.
Well, I have a question. I'm sorry, go ahead and finish your thought there.
Oh, just that other fields also do it, but I think
oceanography now.
I think oceanography has started, but astronomy was the field that started it and has been doing it for the longest.
And for that reason, I mean, it's also got a lot of clout on Capitol Hill because we do this so seriously and as pragmatically as we can. It's not like Ashlee said, this is not some just wish list of everything we want for 10 billion, for 10 years for umpteen billions of dollars. It's an honest assessment of what we think we can reasonably do over a decade's time scale with a decade's time worth of budgets, at least under some budget model. And so that for that reason, you need as much input as you can get into it. And at the end of the day, some people are going to be unhappy with the answers because their thing didn't get prioritized on the top. And if it's not prioritized on the top and it costs over $1 billion or something like that, it's probably not going to happen in that decade. But I'm very glad that the community does this. I think it was almost unique amongst astronomy, but it carries a lot of heft with it because it's so well done and it's taken so seriously by just about everybody.
And it's also built, isn't it, John, on the they start with what science questions do we want answered in the future. So they start with science, not what cool thing would be great to build. They actually need certain scientific, they want to make some scientific progress, and they have to make that case first. And then they go, well, what missions will best address these science needs? And that's why I think it's taken so seriously. It doesn't come with, let's just build something because it's cool. Which, right. I don't know what your thoughts on this, but when I thought the International Space Station was coming along, I always felt like that was a rather ill-defined thing at first when it was the Freedom Space Station, and then they wanted to make it, they didn't really know what they wanted, and I don't even think now it's still got a much of a science case for it to be there, but it was always rather, we're going to do this, we're going to build this space station. But the stuff that's coming out of these decadal surveys, that's not like that at all. It has got justification on a variety of levels.
Yeah, so every time you build a mission or every time you propose a mission, and this is a thing that very few people love, but everybody has to do. You make a thing called a science traceability matrix. And the first column in that is, what is the big picture question you're trying to answer? The second column is, what's the specific science case? And then everything from that is a flow down. What kind of instrument, what kind of observatory, The decadal surveys are constructed in large part off of that same way of thinking. What is the key question we wish to answer? And the community gives the input as to what is the key question for the next decade. And then you flow down from that. Does it mean one big, large mission? Does it mean a suite of small missions? Does it mean a combination of the two? And then we prioritize those things to go back at that first column in the matrix of what is the key science case. And it takes a lot of people and a lot of time to get it done, but it usually gets done right.
So with that in mind, Ashlee, you mentioned something about we usually focus on the first, we prioritize with the first one in the Decadal Survey. What happens to like second, third, and fourth place? Would they do something like what John was suggesting? If there are other science cases, maybe it's a combination of missions we have to build based on those. Does that happen, or is it just the first thing gets built? Because I remember WFIRST didn't get built, I think, and correct me if I'm wrong, because JWST was being built, and they said, well, we're not doing WFIRST now. But then we got those NRO chassis from the guys, and they said, oh, let's build WFIRST now.
Well, a little more complicated than that.
Well, good. Then let's talk about it. This is me being a layman on the outside, not understanding.
But it's true that, and I mean, even the first priority mission, the version that shows up in the Decadal, is still going to be the best version of, or kind of the ideal.
That's going to get the lion's share of approval.
Well, I just mean it's going to be the idealized version. So even
the spherical cow.
The spherical cow. It is the spherical cow. So, for example, WFIRST was the #1 priority from the 2010 Decadal. And the version of WFIRST right now is not quite the same as what was in the Decadal, but it accomplishes the same science
I
goals.
see. Okay.
Sometimes you have ways of either breaking apart missions or putting missions together, or finding as time goes on and as you do full in-depth like these STDTs, or once the agencies actually get involved in the process, or you get Capitol Hill involved in the process.
The SDDT is Science Definition.
Science and
Technology Definition Team.
Yeah, so that's what John was talking about, that he's on for LUVOIR. And so you see that, or for the planetary, Mars 2020 was is a version of the #1 Decadal priority. But you also see planning, and sometimes it happens that it's the second and third priorities get their planning started in that decade, but they just don't make it, they don't actually fly. It depends on a lot of different things. It doesn't mean that they will not happen, especially for the smaller missions, because we tend to fly more frequent smaller missions. Yep. And a lot of the smaller missions also tend to be competed.
Things like TESS, would that qualify? Okay.
Yeah.
All right.
TESS, Kepler. So those missions can't.
Oh, Kepler was a small one. I didn't know that. Okay.
Well, Kepler was a discovery, right? So discovery
okay.
are competing.
Yeah, actually, and Kepler was a discovery mission in the solar system.
Right.
I mean, it's actually a really important point, because oftentimes what the Decadal Survey will do is not specify a specific mission, but instead say a robust portfolio of explorer class missions for which they are not actually saying do this one, this one, this one, but are instead saying over the next decade have this many cost boxed types of missions to make sure you have a healthy portfolio of things, and then those things go out and get competed. The large flagship class missions are in a different box entirely, but oftentimes the Decadal will say it's best for the field if we go out and compete things at the following scales, not determine exactly what we want in this Decadal Survey, but instead define the portfolio. How many smallish missions, how many medium missions, and if it's the case of a flagship, then that's probably a bit more science specific to what that flagship's doing. But it's a really important point that Ashlee's making, is that it's not always a statement of you will build this mission.
Okay.
It's oftentimes a statement of you will have these many boxes of this size over the next decade to think about. Because that gives really important guidance to, say, NASA in terms of how frequently to make a call for proposals for those type of missions.
Then why are you doing things like LUVOIR as I mean, you've got you guys had to define very specifically what this thing is going to do. Why are you presenting that in a Decadal Survey when really you need, because doesn't NASA have, or the National Academies have to say, okay, LUVOIR is #1 instead of check all of these boxes?
Well, I think it's because of scale, because it is a flagship class observatory. I don't want to say flagship anymore, but it is a large,
great observatory kind of thing.
It is, yeah, great observatory kind of thing that doesn't fit into a specifically defined cost box, unlike many of the other mission classes, which are cost capped. Thou shalt not spend more than $250 million on this mission. Is a certain class of mission. The large mission concepts, on the other hand, don't come in saying a specific dollar amount. Instead, we realize that they are large missions which could be very large or moderately large in cost, but we have to instead define, because they are so large and because they take so long to build, a la Hubble and JWST, we have to have as much information going into the decadal as possible in terms of saying, we understand what the technological needs are for something that, if it's going to launch in 20 years, we're going to need to develop this technology in the next 5 or this technology in the next 10, because some of those technologies don't yet exist. And so we have to go through this process, whereas for the smaller box missions, oftentimes those things carry little technological risk or not much at all, because the stuff has already been done today. Instead, it's a specification of competing out these things. Yeah. It all boils down to the scale and complexity of the missions that we're talking about here, as to why we're spending 3 years developing the LUVOIR mission concept, and Habak's team is doing their work, and the Lynx team is doing their work, and OST is doing their work, because these are large scale, large cost missions.
But I would say, to Tony's point, it's a risky strategy. What could happen is the Decadal Survey Committee forms, they get these inputs and they say, we don't like any of these.
Yep. that is a possibility for this.
Although I don't know if that's an interesting point. I don't know if that something like that extreme has actually ever happened. But another point to note, 2 points I want to note, is that a number of missions take more than as we were hinting at, take more than a single decadal survey. An earlier design for LUVOIR was At Last, which was developed nowhere near as depth as LUVOIR is now, but in the 2005, 6, 7, somewhere in there, and was proposed for consideration by the Decadal Survey. And I believe it's had some nice things to say. Good work. It's got good science, guys. Thanks, but no thanks. And the teams went away a little bit disappointed. They tried to build upon a handful of good words in it, and then resurrected themselves in a large part due to NASA funding as LUVOIR now. So many members of the LUVOIR team have had one bite at that particular apple and convinced themselves that the science was really worth doing. And LUVOIR is not the only one. They've had a number of other missions have had multiple opportunities. So that's just part of the game. Also, I think it's worth, since we're talking about process, I think it's worth noting that then there is the fearsome mid-decade review. About 5 years after the Decadal Survey comes out, the National Academies, again contracted by NASA and NSF, will gather very, very clever, very experienced folks, basically to ask NASA and the National Science Foundation, okay, guys, how well are you delivering on what we recommended?
Oh, my. That didn't sound good.
my apologies. I hate my wife.
Step on your cat?
Yeah, that was a decadal, or that was a mid-survey review right there.
That was I thought I'd play for you the sound of the mid-decade review.
It's like herding cats, folks.
Yeah. Actually,
oh my goodness.
So actually, there goes another.
There
cat.
we go. Woo! Hopefully that was the winner. Hopefully he passed his review.
We will have our. Okay, that would be the Ducky. So what the National Academy does, and this is actually once again funded by NSF and NASA, they come in and say, okay, we gave you a suite of activities 5 years earlier. Tell us how well you're doing. Explain yourself. And just a few months ago, about a year ago, the mid-decade review of this of the 2010 Decadal Survey was completed. By and large, NASA did well. Some areas of improvement. So this is a constant effort from the science community, multiple runs at the Decadal Survey and NASA and NSF, constant reviews by the science community and the technology community to see that the progress, or see that the priorities that were given to them at the Decadal Survey, progress is being made. So it's a very, very serious process.
If I can speak to that, that's really important to keep doing, because one of the things that we may want to talk about in the remaining minutes is the fact that there is a rather distinct mismatch in cadence between the decadal surveys, the mid-decadal surveys, and the budget process. Yeah. Because the budget process is a yearly thing in an ideal world. And
the United States hasn't had a budget in
that idea.
Yeah.
But we as a community have to reassess on timescales, at least not always every decade, the imprint of budget realities on our ability to execute those priorities. And I strongly suspect that the next decadal survey is going to be paying a little bit more attention to various budget realities and budget processes and budget prognostications than they might have in years past. Because the original decadal survey for the 2010 had a budget projection that does not match what the budget reality is in this year today. And so it's an important piece that's becoming more important in the era of flat being the new doubling for budgets at NASA, NSF, and DOE Office of Science.
Right.
So I don't know if Joel and Ashlee want to speak to that piece of the budget thing, just to give a sense of what timescales are for the budget process, or whether or not that's a direction we want to go. We've only got a few minutes left.
Yeah, we've got a few minutes, and I do want to get some comments on the budget process, but I also want to talk about the international component to this as well. So so what about that? So you've got, I don't think the United States has had a budget approval in many years. We've just sort of had these continuing resolutions. I don't know much about it, but and NASA's policies almost always have to be both because it's a political football and a budget one. All of their goals they seem to have to make sort of multi-purpose. Well, if the priorities become this, then we're going to, this project will meet any number of priorities that might come about. Like, we can develop the Orion spacecraft. It'll get us to the moon. It'll get us to Mars. Wherever we're going to go, we'll develop the Orion spacecraft. And it'll work regardless of where we headed and what the money is. Your comments on the budget versus the timing of the decadal surveys, and maybe NASA's priorities as well?
So I'll say that so projects are the most vulnerable in the first year or two of their introduction into the budget. But generally, once something as large as, say, Webb telescope, or even half its size, gets sort of bending metal, as they say, and you really do start to get a lot of people working on it, Congress and the White House tend to abide by those year-by-year construction. There's a profile, budget profile, and everybody tends to get on board as long as the project is well-behaved. So it's really those first couple of years and any budget uncertainties that are the main source of stress. Obviously, Webb went through a big cost growth, and there was not question would it get canceled. Big projects, they say, usually go through at least one or not two near-death experiences before they finally get done, and Webb wasn't any different there. But I think that people realize we've already spent $3 billion on this. Maybe we should think twice about canceling it.
Yeah, and that happened. Yeah, so that's a good point. Okay, Andrew Planet's got a question that's related to this. Wouldn't it be less costly to build a space telescope that can perform in all of the specialist ranges that other space telescopes are singularly designed for and still be as good as any one of them? In other words, can we build a telescope that takes into as much of these sort of a one-size-fits-all kind of model, build that, and maybe cover all of the bets?
Well, I mean, that is part of the philosophy driving the larger mission concepts, is that they tend to be more capable across a wider spectrum of things. If I take Hubble as the textbook example, it covers a very wide range of wavelengths, and it has extremely flexible instruments on it, as opposed to some of the smaller missions, which are very focused on a specific wavelength range and a specific question. Yeah. So the larger ones, LUVOIR is a good example of this, and Webb is a good example of this. Their instrumentation packages and this, that, and the other thing are trying to capture as robust a portfolio of science questions as they can. You can't build any one telescope that does gamma ray physics and radio astronomy at the same time. That's technologically infeasible. But for the very large mission concepts, I think it would actually be a requirement going in that you can do as robust a science portfolio as you can, or that's really not a good investment. Then it would be a better investment to invest in smaller things that are more capable of specific questions.
Right. So, and
if you want to go after specific science questions that require really big apertures, at the same time, you better build an observatory that can do a whole lot of things. Otherwise, I really don't think it's worth the investment.
right. So Andrew, being less costly might not be, but LUVOIR comes the closest from the UV all the way to the infrared wavelengths. Plus, it'll have a lot of different instruments on board.
I mean, I think the important thing that I would phrase things in is not cost, but science per dollar. That's the thing that we really want to maximize across the portfolio, from small missions to large missions, is whether or not they're returning the science per dollar.
What is that? What is the units of science per dollar? I mean, so science would be in what, discoveries, or what would the science unit? What would the science unit be?
John is exactly right. Although the science per dollar is can often be a philosophical issue.
That was my point. Yeah.
Qualitative issue, although the point that John makes is a good one. That issue comes up often.
Okay.
You can also have small missions that can be very efficient at doing one specific thing that has a large science return. So to go like the Kepler mission is a very specific mission. It's just a camera that stares at one point in the sky, and it's very, very good at doing that. It's a very sensitive instrument, and it doesn't do much else. It turns out that there are lots of other interesting applications that come from that science, that you can do more than just discover exoplanets, that you can watch active galaxies evolve and all sorts of other fun things. But sometimes that we do these smaller ones because you can efficiently, for a reasonable cost, get a lot of science return from a simple.
Well, in the case of Kepler, that's a great example. Talk about science per dollar being really high. After the mission was over and the reaction wheels failed, they were still able to get more science out of it using the pressure from the sun to now do different kind of science than what it was originally designed to do. So I think that was a good example.
Yeah, I think Kepler is a fantastic example on the small end, and the Hubble Space Telescope is a perfect example on the large.
Except that, and I always say this about Hubble, we got to go up there and repair the thing.
I'm integrating the cost for that, all of that stuff in.
You're still saying science per dollar. Hubble was a good bet. I still think
the science per dollar for Hubble and for Kepler and for many of the medium class missions are those are the things we should aspire to every time we want to go and invest large quantities of taxpayer dollars. Is missions that have that kind of return.
I agree. Now, we only got a couple minutes, and I really just want to hurry up. I want to talk about other countries with all of this. National Academy of Sciences, the Decadal Survey, NASA, National Science Foundation. That's the United States. That's what we're doing. Are we paying attention to the rest of the world and integrating their priorities, and can we get help from the European Space Agency, for example? They're doing great work. And I know we do things like, they build this component or that component, but is there a way to make this is it a worldwide effort, this decadal survey, or is it mostly just the United States going, this is what we find important?
So the Decadal Survey is a United States effort in that it is paid for by the federal agencies asking the national academies to put this together. But the Decadal Surveys take into account what is happening around the world. There are often complementary or different kinds of missions that ESA might be running.
And they get briefings throughout from the other space agencies around the world. Many times the Decadal Survey Committee itself will have prominent international astronomers as members. So you not only get briefings, but you get membership on the key committees that come from other countries and know what they're planning in Europe or in Asia.
Well, does the International Astronomical Union, the international body that I sort of look at as the National Academy analog, does it have any sort of process like this? Does it go through any kind of prioritization of anything like this, or is it?
Not the IAU, no,
they don't do anything like this. I see.
No, but
it's more with individual regions and countries.
Okay.
The National Space. Joel just said this. Yeah, the National Space Agencies and the European Space Agencies all go through. I think none of them are all identical, but they all go through.
Okay, and real quickly, I have a hangout on Wednesdays with an astronomer from Hawaii, Jeff Kuhn, and he makes the point that the days of one size fits all telescopes are a thing, or we need to stop thinking that way. But he also says that most of the biggest ground based observatories that were built in history have been done by using private dollars, and things like Palomar, Lowell Observatory. These were all built using private money. Is there a role to play in space astronomy for private money? I know it's not a profit-making thing, but neither was the Lowell Observatory when it was built. Is there a role for private dollars to play in this process so that we're not relying on taxpayers all the time?
I think if Elon Musk wants to give us $10 billion to build a space telescope, we'll build a space telescope with that $10 billion. I think it's also, but it's largely a question of risk, right? I mean, and the capability to have all the infrastructure that you need to build those things. And it's true that most of the large ground-based telescopes were done with private dollars, but the scale of that investment is still slightly different. When you're talking about, $100 million versus $10 billion, that's a vastly different scale.
Well, okay, but I don't know about that, because Palomar was a big deal when it was built. It was not cheap, and it was built with the scale of it, I think at the time was pretty extraordinary. Wouldn't you say?
Yeah, but I think at the same time, that's in part because they could walk up and see it.
You think that's a big part of it?
It's a big part of it.
Okay.
So
you're not sounding enthusiastic about private people.
Well, I wouldn't say for the flagship ones. It's entirely conceivable one of these smaller, like a Kepler size, could be afforded by some gazillionaire.
If somebody has $14 million a year, they can rent Spitzer.
Yep. We just put a proposal out for that. NASA just put a call out.
What? Really? It's out for rent? You can rent Spitzer? Spitzer, by the way, is an infrared telescope that was launched many years ago. It has since run out of coolant, so it can't do its primary mission, but it still has a lot of really good infrared detectors, and it's still contributing to discoveries even now. So
NASA would loan it to you, and you would get to operate it at about $14 million a year.
I didn't. That's really cool. There you go, folks. Let's start a Kickstarter. I'll start one up, and we'll get 14 million, huh? Okay.
Yeah.
I suppose I see your point, though, John. I mean, this scale of this is extremely, and I'm not even really talking about making a profit, because that wasn't an issue with those early ground-based observatories. They didn't build those to make money. They built them to further scientific progress, and I just wonder if we can get that going in this age anymore, or if it's just a lost hope. Okay, well, I guess we are out of time. I am. I don't want to leave it on a
lost hope. I don't like ending with lost hope.
Yeah. So.
Say, by the way, and before we go, and before we thank our three guests, we do want to thank the two AASs. The two sponsoring organizations of this activity.
They're down in the banner below here.
Right down below here, the American Astronautical and the American Astronomical Society, through whose generosity and thoughtfulness makes this possible.
That's right. And I want to thank my guests, Dr. John O'Meara. He's a professor and chair of the Department of Physics at St. Michael's College. He's also a member of the science definition team for LUVOIR, the upcoming, hopefully, one of the, I don't know who to root for, but I would love for LUVOIR to make it. Also is Dr. Joel Parriott. He's the Director of Public Policy at the American Astronomical Society, and also Dr. Ashlee Wilkins. She's the Bacall Public Policy Fellow also at the AAS. Thank you all so much for giving us information on how things get funded, how we decide what future astronomy missions get made. This has been, I learned a lot, and who knows, if you guys wanted, maybe we should get together and do Spitzer, guys. Let me know.
I got my wallet ready, man.
You do, yeah? All right, so John's in, I'm in, so that's
first 50 callers also get a Kepler image.
The first 50 callers get your own Kepler image.
$27.
Oh, look at that, boy! Joel's got his wallet out. That's awesome. We are ready. We're there now. I'm sorry I didn't get to a lot of your questions, folks. I saw you guys were chatting about a lot of other things, but I did see some questions on JWST and building ground-based telescopes. So, and that really wasn't the topic of this particular discussion. So I'm about to head over to Twitch. I'll be there in about 2 minutes if you want to ask me some more questions. So thank you all so much for watching, and as always, keep looking up.
Bye-bye.
Bye.
I've got a question for Joel and Ashlee, though, first.